Alright, so now we're going to solve the Chapter 2 test. Haven't made the solutions, so we're going to go through this. Might get a little sloppy, but let's see. So, we've got this problem. A giant resistive circuit, power source. Each one of these kind of has to add up, and it's asking for VL. Should have made that a little clearer. And where's VL? This one. So, first thing that we're going to look at, remember, we can reorder circuits. So it doesn't matter if you have, let's just put 3 together. R1, R2, R3. Or if I make that equal to R3, R2, R1. So it doesn't really matter which you do in which order. So again, this VL here is going to be the same as moving it up here, but these are already the same. So essentially, I can say positive minus VL is the same at this spot as to this one. So I'm just going to call this one VL to save me from calculating every single part of this thing. Although you can always calculate down through and grab this one too. Both are the same because it's 1, 2, 3 or 3, 2, 1, however you want to do it, or 2, 3, 1. This could come in front of this and the parallel part could come to the bottom. Again, it doesn't matter. So let's start. So we're going to get a, let's look at what we got. We got 1, we've got this, around this, and this goes off to the source. This is going to be 1. These, I just simplified these two parallels. So this first one's going to be 5. Then we have 5 over here. We have 5 down here. We have 5 over here. And then this one, 1 over 6. 1 over 6 plus 1 over 10 to the minus 1 is going to equal what? 3.75, I think, right? 6 times 6. So the other way to do this, 6 times 10 equals 60 divided by 16. Yeah, 375. All right, so that's what this one is, 3.75. And now we're going to solve for this one. 1 over 6 plus 1 over 4 minus 1 is going to equal, the calculator, 2.4. Okay, 2.4 there. Okay. So now what we're going to do is we're going to solve up through that. Let's simplify this out. This is 5, 10, 13.75. So we're going to have coming through here on this side is a single resistor, and this is going to be 13.75. And this one's going to be 12.4. It's going to go back out to our source. Okay, so we're going to do this one again. 1 over, or 13.5 times 12.4 divided by 13.5 plus 12.4 equals, what does our total equal? 13.5 times 12.4 divided by 13.5 plus 12.4, 6.46. 6.46, somewhere around there, equals our total. Our total. Cool. So now we have our total set up here. Let's see what the next bit is. So that's going to be, essentially, if we come over here, it's a single resistor, and then that value is going to be 6.46. So now what do we have to do? If we have R total, V total, T total equals I total, R total. So this is going to be I total, or just I total, whatever you want to call it, up here, the big one coming in. V total equals I total, R total. We're going to get V, which is what, 12 volts, equals I total times 6.46. 6.46. IT equals 1.84. Okay. Now we've got this point. So now we know this is 1.84 coming into the top of the circuit. It's going to split 2 ways. If these were all perfectly even on this side and even on this side, it would go 50-50. But since we know it's not quite even, it's a little bit more resistance on this side, a little less, a little more current is going to go through this side, a little less current through this side. So what we've got here is we're going to do our V 1 equals I1 R1. So I'm counting this whole side as our R. So what I'm trying to do is find the split. So there's also the current divider equation that we have there in the book, or you could do it manually. It doesn't matter how you do it. But this is V1 equals I1 R1, and I'm talking about this whole side. So we've got the voltage up here, which is still 12 volts, equals I1, we're not quite sure. R1, which is this entire side over here, is 13.75. And then we're going to have I1 equal, what is that, 0.87. Okay, that looks good. And then, of course, we're going to have, so we have 0.87. Now we're going to do, again, so we have the current coming through here. Let's just do this. This is going to be called I1. I1. Now that we have the current going through there, we're going to do VL equals I1 5 ohm resistor. Oops, pull that down. 5 ohm resistor because it's going through that 5-1. So we're going to get VL equals 0.87 times 5. VL equals 4.35. Done. Oops, there we go. Cool. Move on to the next one.